Hello everyone, welcome back to this video. In this video, I will show you lab 9. In lab 9, we will recall again what we have done before to improving our FPGA design or our device design. In this design, we will using the direct Gaussian transform device to design the direct Gaussian transform into device, and then we will improving using the memory bandwidth and also data flow. So there are two kind of improvement that we will use in this lab. The first one is improving the memory bandwidth. So we will make the memory larger. And then the last one is applying data flow to make the latency more faster. The first one you need to do is open the lab 9 and we will run the direct Gaussian transform TCL file. As usual, we will open the VTIS HLS command line to make a new project. CD, and we will move to the Active Directory and run the TCL file. And press enter. In this TCL file, we only doing the C simulation, and after that we will doing the improvement. Now the C simulation already done and the results are good. Now we will open the project VTIS HLS -B. What is the name of project? TCT project. Okay, we already make a new, and then synthesize the design. Now we'll synthesize the first solution 1 in the design. Okay, now we have the report here, how many latency, how many the interval is only one. It's only one, and then we have a memory bandwidth in here. The top function. Now I will open the specific report. This is the synthesize. The latency is 404 404. Maximum is 413 405 in here. A little bit different. 405 404. Okay, you can write your latency in here, in file in here. We have 404 and 405. Now we will see how many VRAM and LTU and URAM. The available VRAM is 624. What we have in here, wait, default solution is 17 VRAM. Okay, and how many DSP? 16. Okay, 16 FF 751. Okay, and 1591. Okay, the memory same, the interval same, latency same. Now we will improve the memory with memory bandwidth into the second step. In second step, the first we need to do before we apply the optimization. Now we will check the solution and open the analysis, and we can see how many loops that it have. How many loops? One iteration and trip count 64. We have that report. And the latency is 404, as we said before, because the loops in every function still have 64 loops in here. 64 loops in here. You can see how many VRAM is used in these loops, and how many LUT that you use in that loops. So you can analyze first which one is bigger, which one is smaller, And in this solution, we make a co-simulation first, doing the co-simulation first, and we will see how many how many memory bandwidth that we should have in here, and is passed or not. Let's come back into debug and project, doing co-simulation, and let them into default setup and press OK. Okay, already passed and OK. This is the average latency as we have see into the from the C simulation and C synthesize 404. Now we will make a new solution. We will make a new solution to doing the memory bandwidth with array partition. We will increase the memory bandwidth with array partition. New solution and finish as a second solution. Now apply the array partition into buffer 2D and buffer and the column function 2D and the column function. We will check first why let's make an active solution first. I will check why we allocate into buffer to the allocation, or because this is the smaller VRAM. Okay, we will apply into input data and column input buffer, because we will increase the memory bandwidth in the input of the our design in the DCT, because it need many resource in the input to process the data first. So we will increase the memory buffer of the input. So we will apply the buffer to the input and the column input buffer. Move to debug, synthesize, and let's apply again in the solution. Now in the DCT we will apply into DCT input. Where is input? Buffer to the input, insert directive, and we will apply the array partition, completely partition, complete, okay, and move into column input buffer, array partition, complete. So we will see, wait, dimension option is 2. Let's check again. It's 2 or not. Dimension partition is 2. Because it have 2 row, 2 column and row. So we will divide it into 2 dimension directly, not in 1 dimension. And now we will run the C synthesize. We will run the C synthesize. After we are inserting the array partition, the latency it's still the same, but we will see the allocation of memory will increase, LUT, but the VRAM will be optimized here because we move all the input buffer into completely partition, so not using any memory at all. I mean using less memory because the input is the array input is in parallel, completely spared. Okay, this is our solution after improving the C synthesis. I'm improving using the array partition. Okay, latency still the same, interval same, but the VRAM is using only 3. Okay, let's compare reports, solution 2 and solution 1. Now you can see that in the solution 2, that after we are using the array partition, the VRAM will be less than the solution 1 that not using array partition. So the first thing that we need to do is improving the memory usage, and you can see after improving the memory usage, the LUT lookup table is so many, so the results will be optimized. The results from the FPGA using the LUT will increase, and you need to check is available or not. Yeah, is still available, still enough, still enough. The LUT is still enough. We are using ZCU7. ZU7 is still enough. Have how many? 230,000 lookup table. It can fit and 624 PRAM. So it still fit into the device. You can check it first, and after improving the array, improving the memory using the array partition, now we will move to improving using the data flow, but we will analyze it first. As you can see in the previous solution, in the first solution, there is only one buffer allocated, but now after the partition they will have many array allocation in the input, so directly process the input into many partition, not one by one. If one by one, they will use many memory allocation, but now we use a device allocation, so increase the buffer, increase the data bus in the input. They will reduce the memory usage. Now we will improve using a data flow as the previous lab we have done before. Data flow. Okay, let's make a new solution. Let's make a new solution. New solution as the third solution, and move to the directive, and using a data flow, insert directive, data flow, and okay, directive in DCT, using a data flow, this one. Okay, and using this DCT, now we will synthesize. Okay, this synthesis is finished. Now we will compare the solution 3, 1, 2, 3. Okay, now this is the comparison. As you can see, even the latency is almost same, 404, 404, 406, but the internal or the interval from another cycle to another cycle is reduced from 405 to 273. This is our third solution. So the performance will be increased because the interval cycle is reduced than the previous solution after using the data flow. And keep maintain the memory usage be RAM here, but just slightly increase the LUT. This is good for our design since only increasing several LUT that's still suitable and fit into our uh, Z ZU7 XU7. Now and the last one, we can analyze uh, the loops of our device. How many interval? Okay, 270. This one. Okay. The loop is same. Oh, I remember. We force the DCT to D with removing uh, some some loops in here because wait, this only for loops. Now we will check in the first solution or in the second solution. We will check the second solution. Yeah, we have many loops in here. 1 2 3 4 5 6 loops, but after uh, after doing the pipeline, I mean doing the data flow, now active solution and analyze. Now they only have 4, so the latency will reduce because they make some pipeline and also make the data flow to optimize the performance of the internal interval latency. Yeah, they decrease some loops, so our design performance is increased from the first solution to the last solution. I think this is our labs today, so you can follow this improving area. The first thing that you need to do is improving the memory usage using array partition, so you can make the difference. Array partition is the purpose of array partition is improving the memory usage in your device, and for the data flow is improving the latency. You can search which one is better, which one can improve or not, because you can see the results of your device is enough or not, the LUT is enough or not, because all optimization need many results in LUT. moving from RAM to into LUT, into logic device. So I think that's all. This is our this is in the video. See you into the next video.